Tachikawa Army Air Arsenal, Tokyo, November 30th, 1944. Captain Saburo Nakamura, Imperial Japanese Army Air Service engineer, stood inside the pressurized forward compartment of a captured B-29 Superfortress. The bomber had been forced down in China 3 weeks earlier, recovered by Japanese ground forces, and transported to Japan for technical examination. Nakamura placed his hand against the curved metal wall. Outside, the hangar temperature was 8 degrees Celsius. Inside the sealed compartment, it felt comfortable, almost warm. He checked his notes. American crews reported the pressurization system maintained cabin conditions equivalent to 8,000 feet altitude, even when flying at 32,000 feet. Japanese interceptor pilots at 32,000 feet were gasping for oxygen through crude masks while fighting hypoxia. American bomber crews sat in shirt sleeves, breathing normally, operating complex equipment with clear minds.
For 18 months, B-29 Superfortresses had bombed Japan from altitudes Japanese fighters struggled to reach. When interceptors did climb high enough, pilots experienced tunnel vision, impaired judgment, and physical exhaustion. Combat effectiveness collapsed above 28,000 feet. American bomber crews showed no such limitations. They flew higher, stayed longer, and operated defensive guns with accuracy that suggested they weren't fighting altitude-induced hypoxia at all. Japanese intelligence knew the B-29 was pressurized. What they didn't understand was how that single technological advantage had rendered Japan's entire air defense doctrine obsolete. Over the next 2 weeks, Nakamura's team would disassemble the B-29's environmental control systems. They would test the pressurization equipment. They would examine the oxygen delivery systems. They would measure, photograph, and document everything. Their report would confirm what Japanese commanders feared. American aviation engineering had solved problems Japan didn't know existed until bombs started falling from altitudes their fighters couldn't effectively defend. This is the story of what Japanese engineers discovered when they examined a captured B-29's life support systems, the technological gap they documented, the manufacturing sophistication they couldn't replicate, and why high-altitude air combat had become a battle Japan was losing before pilots even engaged the enemy.
B-29 Superfortress, serial number 4224627, nicknamed Tokyo Rose, departed Chengdu, China at 0630 hours on November 7, 1944. Mission: bomb Mukden Aircraft Factory in Japanese-occupied Manchuria. Aircraft Commander: Captain William Hayes, 468th Bombardment Group. The mission profile called for bombing from 28,000 feet, well above effective Japanese anti-aircraft fire and at the upper limit of most Japanese interceptor capability. 37 B-29s participated in the raid. Hayes's bomber reached the target without incident. Bombs away at 11:42 hours. Direct hits on the factory complex. The formation turned for home.
At 12:03 hours, approximately 60 miles southwest of Mukden, number 3 engine lost oil pressure. Hayes shut it down and feathered the propeller. Standard procedure. B-29s regularly return to base on 3 engines. But at 12:27 hours, number 4 engine began running rough. Probable fuel contamination from a ruptured fuel cell damaged by anti-aircraft fragments. Hayes reduced power on number 4, but the engine continued losing power. With 2 engines compromised on the right side, the B-29 couldn't maintain altitude. Hayes descended, looking for emergency landing options. Chinese territory was 200 miles away. Japanese-controlled territory surrounded them. At 12:45 hours, Hayes spotted a dry riverbed. He brought the massive bomber down in a wheels-up landing that his crew would later describe as surprisingly gentle. The B-29 slid 400 meters and came to rest largely intact. The crew had approximately 30 minutes before Japanese forces arrived. Standard procedure: destroy classified equipment, set demolition charges, evacuate. But the demolition charges failed to detonate properly. The forward fuselage, including the pressurized compartment and nose section, remained intact. By 13:30 hours, Japanese soldiers secured the site. By 1400 hours, technical intelligence officers arrived. By November 10th, the B-29's forward section was on a flatbed truck headed for Tachikawa Air Arsenal outside Tokyo. Japanese High Command issued Priority 1 directive: examine the aircraft's high-altitude systems, determine how American crews operated effectively at altitudes where Japanese pilots could barely function.
By late 1944, Japan's air defense against B-29s relied primarily on 3 aircraft: the Kawasaki Ki-61, Tony, the Nakajima Ki-84, Frank, and the Mitsubishi J-2M, Jack. All were capable fighters at low and medium altitudes. But above 28,000 feet, their performance degraded dramatically. The Ki-61's engine lost power. The Ki-84 took over 20 minutes to climb to 30,000 feet, by which time B-29 formations had already bombed and departed. The J-2M was designed as a high-altitude interceptor, but suffered chronic engine reliability problems. More critically, Japanese pilots above 28,000 feet fought 2 enemies: American bombers and physiology. Even with oxygen masks, pilots experienced hypoxia symptoms, tunnel vision, delayed reaction times, impaired judgment, physical exhaustion.
Japanese aircraft used demand-type oxygen regulators. Pilots breathed through tight-fitting masks that delivered oxygen when they inhaled. The system worked adequately below 25,000 feet. Above 28,000 feet, the system's limitations became deadly. Mask seals leaked. Regulators froze in cold temperatures. Pilots had to actively inhale against system pressure, a tiring process during violent combat maneuvers. Japanese pilots reported that engaging B-29s at altitude felt like fighting while running a marathon. By the time they reached firing position, they were physically and mentally exhausted. Gunnery accuracy plummeted. Tactical thinking deteriorated. One Japanese ace, Master Sergeant Satoshi Anabuki, documented in his diary, "At 10,000 meters, 32,800 feet, I positioned behind B-29. Vision narrowed, hands shaking. Fired 200 rounds, saw no hits. Bomber crew returned accurate fire, forced to break off. Descended feeling ashamed I could not press attack." By November 1944, B-29s were bombing Japan with relative impunity. Japanese fighters attempted interceptions, but kill rates remained below 2% per raid. Most B-29 losses came from mechanical failures and accidents, not enemy action. American air crews reported that Japanese fighters rarely pressed attacks aggressively above 28,000 feet. When they did attack, their gunnery was notably poor compared to fighters at lower altitudes. Japanese commanders knew why. Their pilots were fighting at physiological limits, while American bomber crews operated comfortably. The altitude itself was a weapon Japan couldn't counter. November 30th, 1944. Nakamura entered the B-29's forward pressurized compartment for the first time. The compartment was spacious, large enough for 4 crew members to operate side by side. The pilot and co-pilot sat in comfortable seats with full instrumentation. Behind them, the bombardier and navigator had their own stations with ample workspace. Everything was designed for crew comfort: padded seats, adjustable backrests, heating ducts providing warm air, sound insulation reducing engine noise to tolerable levels. Nakamura compared this to Japanese bomber cockpits: cramped, noisy, cold at altitude, with minimal crew comfort considerations. Nakamura's team began systematic examination of the environmental control system. The B-29 used engine-driven compressors that bled air from the engine's superchargers, pressurized it further, and pumped it into sealed compartments. The system maintained cabin pressure equivalent to 8,000 feet altitude, even when flying at 32,000 feet. This meant crew members experienced atmospheric pressure similar to Denver, Colorado, high enough to require adjustment, but not dangerous or debilitating. The pressurization was automatic. Pilots didn't manually control it. The system compensated for altitude changes, maintained steady pressure, and included redundancy, If one compressor failed, others compensated. Japanese engineers had theoretical knowledge of cabin pressurization. German engineers had developed pressurized high-altitude aircraft. But implementing it reliably in a combat aircraft at production scale was an engineering achievement Japan had not accomplished.
The B-29 also carried supplemental oxygen systems. If pressurization failed due to battle damage or equipment malfunction, crew members could use individual oxygen masks. But crucially, the supplemental oxygen was a backup, not the primary system. American bomber crews at 32,000 feet breathed normally most of the time. Japanese fighter pilots at 32,000 feet breathed through masks constantly. Nakamura's report noted, American crew members operate complex equipment at extreme altitude with full cognitive function. Pressurization eliminates physiological stress. This provides enormous tactical advantage. Bomber crews can focus entirely on mission, not survival. The psychological impact was equally significant. American crews felt safe and comfortable even at altitudes that terrified Japanese pilots. Morale and effectiveness reflected this fundamental difference.
The B-29's pressurization compressors were compact, reliable, and powerful. They operated continuously for hours without overheating. Nakamura's team tested the captured units. They functioned perfectly despite the aircraft's combat damage and forced landing. Japanese industry had manufactured compressors for industrial applications, but aviation-grade compressors required different specifications: lightweight, high reliability, cold weather operation, resistance to vibration. Japanese attempts to develop similar aviation compressors had failed repeatedly. Test units overheated, leaked seals, or proved too heavy for installation in production aircraft. Nakamura's team examined the pressurized compartment's construction. The hull required perfect sealing. Any air leak would defeat pressurization. This meant precision manufacturing of curved metal sections, high-quality gaskets and seals, and reliable riveting techniques. American manufacturing achieved this consistently across thousands of B-29s. Boeing produced over 3,900 B-29s during the war. Each one's pressurization system met specifications: interchangeable parts, consistent quality. Japanese aviation manufacturing struggled with much simpler consistency challenges. Producing a reliable pressurized bomber at scale was beyond Japan's industrial capability in 1944. Captured American technical manuals revealed another gap: crew training for pressurized flight. American manuals described procedures for gradual pressurization, emergency depressurization, and handling cabin pressure failures. The training assumed average crew members could master these procedures quickly. Japanese pilot training emphasized courage, spirit, and tactical aggression. It didn't include advanced physiological training for high-altitude flight because Japanese aircraft couldn't sustain prolonged high-altitude operations. The result: American crews were trained and equipped for high-altitude combat. Japanese crews were brave, but physiologically unprepared for sustained operations above 28,000 feet. The captured B-29 had 12.50 caliber machine guns in remote-controlled turrets. Nakamura's team examined the gunnery stations where gunners operated sitting in pressurized comfort. Japanese fighter pilots reported that B-29 defensive fire was devastatingly accurate. Now, Japanese engineers understood why. American gunners at 32,000 feet sat in heated, pressurized compartments. They tracked targets using sophisticated computing gun sights. They aimed with steady hands and clear minds. No hypoxia, no oxygen mask restricting vision. No cold-induced trembling affecting trigger control. Japanese bombers, primarily the Mitsubishi G4M Betty and Nakajima B6N, carried defensive armament but operated without pressurization. Gunners at altitude wore oxygen masks and heavy flight suits. They operated hand-aimed guns while fighting cold and hypoxia. Defensive accuracy suffered accordingly. American fighter pilots reported that Japanese bomber defensive fire above 25,000 feet was notably weak and inaccurate. The pressurization advantage extended beyond the B-29's offensive mission. It made the aircraft defensively more lethal. Japanese fighters attacking from behind faced accurate return fire from gunners operating at peak efficiency. Captured American aircrew interrogations revealed psychological advantages. B-29 crew members described high-altitude missions as cold and boring, rather than terrifying and exhausting. Japanese pilots described the same altitude as a hostile environment, where every minute required maximum concentration just to function. Nakamura's report included a section on psychological warfare. Enemy achieves strategic bombing objectives while maintaining crew morale. Pressurized comfort reduces stress. Crews can focus on tactical execution rather than survival. This maintains operational efficiency over extended campaigns. Japan's bomber crews grew increasingly exhausted as the war progressed. American B-29 crews, while facing combat dangers, didn't experience the physiological exhaustion that depleted Japanese aviation strength.
Nakamura's report reached Imperial Japanese Army Air Service headquarters in early December 1944. The response was predictable: develop comparable pressurization systems, improve Japanese high-altitude capabilities, counter the B-29 threat. Japanese aviation engineers responded that developing pressurized bombers or fighters would require new compressor manufacturing capability, precision hull manufacturing techniques not currently available, complete redesign of existing aircraft, minimum 18 to 24 months development time, resources that didn't exist in late 1944 Japan. The directive was technically and industrially impossible.
Japan did attempt high-altitude fighter development. The Kawasaki Ki-88 and Tachikawa Ki-94 were designed with pressurized cockpits and high-altitude capability specifically to counter B-29s. Both programs failed. Engine problems, manufacturing delays, material shortages. By the time prototypes flew in 1945, B-29s had already burned much of Japan's industrial capacity. Even if these aircraft had reached production, Japan lacked the fuel, pilots, and industrial capacity to deploy them effectively.
Japanese fighter units adopted desperate tactics: night interceptions where altitude disadvantages mattered less, ramming attacks by pilots willing to sacrifice themselves, ground-based searchlight coordination to track high-altitude bombers. These tactics achieved isolated successes but couldn't stop the strategic bombing campaign. B-29s continued attacking, and Japanese intercept kill rates remained under 3% through early 1945. The altitude advantage, enabled by pressurization, had made America's strategic bombing campaign unstoppable with available Japanese countermeasures. By March 1945, American strategy evolved. General Curtis LeMay ordered B-29s to attack from lower altitudes, 5,000 to 8,000 feet, using incendiary bombs against Japanese cities. The pressurization advantage became less critical during low-altitude missions, but by then, Japan's air defense capability had collapsed. Fighter strength had fallen below 1,000 operational aircraft. Experienced pilots were dead or grounded by fuel shortages. The March 9-10 Tokyo firebombing killed approximately 100,000 civilians. Japanese fighters attempted intercepts but shot down only 14 of 334 B-29s, a 4% loss rate that American commanders considered acceptable.
The atomic bomb missions to Hiroshima and Nagasaki were flown at high altitude, 31,000 feet for Hiroshima, 28,900 feet for Nagasaki. Japanese fighters attempted interceptions of both missions. They failed to engage effectively. The pressurization advantage that Nakamura had documented in November 1944 ensured American crews delivered atomic weapons while operating at peak physical and mental efficiency. Japan surrendered on August 15, 1945.
The B-29 strategic bombing campaign, enabled significantly by high-altitude pressurization technology, had destroyed Japan's capacity to continue fighting.
When Captain Nakamura examined that captured B-29's pressurization systems in November 1944, he documented a technological gap that Japan could not close. American engineering had solved high-altitude flight challenges through systematic innovation, reliable compressors, precision manufacturing, crew comfort design, and integration of all systems into combat-ready aircraft produced at industrial scale. Japanese industry possessed theoretical knowledge but lacked the manufacturing capability, resources, and time to implement comparable solutions. The altitude itself became a weapon. B-29s bombed from heights where Japanese defenders fought at physiological limits, while American crews operated comfortably.
After the war, Nakamura worked with occupation authorities documenting Japanese aviation technology. He provided his B-29 analysis reports to American intelligence officers, who used them to understand Japanese perspectives on technological gaps. In a 1952 interview, Nakamura reflected, "We examined that B-29 and understood immediately why Japan was losing the air war. The pressurization wasn't a luxury, it was a combat multiplier that made every other system more effective. American crews at 32,000 feet operated as if at 8,000 feet. Our pilots at 32,000 feet fought to remain conscious. The battle was decided before shots were fired." The B-29's pressurization technology represented more than engineering achievement. It demonstrated how systematic innovation, solving problems most nations didn't recognize as solvable, could determine strategic outcomes. Japanese pilots were brave, their aircraft were capable, their tactics were sound. But they fought at altitudes where human physiology became the enemy, while American crews breathed comfortably in pressurized cabins designed for crew survival and combat effectiveness. Sometimes the most decisive weapons aren't the ones that destroy the enemy. They're the ones that let your forces operate where the enemy cannot.